I'll be showing you everything you need to enable Stripe in your e-commerce application. We will also build classes to store our orders, along with sending the information to Firebase. This gives you an idea on the information you need to collect for your user in order to make a successful payment. As you can see, this is an ongoing tutorial series, but if you're just seeing this video and just want to learn about checkouts and orders without going to our previous videos, you can check the description to see the code for this actual tutorial where we're going to start from. Also, if you just want to learn about Stripe, you can use the chapters to skip to that section and continue from there. But I'll advise you to stick around because we would learn a lot during the course of this video. So, without wasting any time, let's start writing some code. In any e-commerce checkout, there are two screens you will need, and those screens are the checkout screen and the successful screen. Let's make the checkout screen a stateful widget, and the checkout success screen a stateless widget. We'll get back to that later in the video. In this checkout screen, we'll add all the fields that are required for checkouts, including the fields that are required for Stripe. And while we are here, I would like to mention one thing I require you to do, and that is to subscribe to my channel. So if you've not subscribed, I really appreciate it if you do. You can also like the video so that more people can get this information I'm providing right now. So let's get back to the video. In this field, we'll collect all the information we need to fulfill this order. So on the app bar, we'll just have text. To move to this our checkout screen, we'll have to go to our bag screen, and within our button, we'll add a navigator to move to this page. Let's add some items to cart so that we'll be able to navigate to this checkout screen. So once we click on this button now, we are taken to the checkout screen. On our checkout screen, within the body, we'll add a list view. We're making use of a list view here because we want the item to scroll once they overflow the size of the page. So if you're using this application on a smaller screen, you can scroll up or scroll down without it affecting the UI. We'll be using a text form field to enter our information. This is because it is an input field, and also it allows validation of the input field. We'll look at validation very soon. I will add a decoration. This is where I'll give it an outline around the border. Let's add a validator to this form field. A validator checks if the input to this field is actually valid, as the name implies. So for this validator, we'll just check if the field is empty. So what this code does is it checks the text, and if it is empty or null, it shows the information to enter a valid name. But if there's an actual input into the text field, it returns null. Returning null in a validator means the form is valid. For our other fields, I'll copy this and duplicate it for each of them. We'll use our custom primary button at the bottom of this screen. This is the button that we'll use to make payments later in this video. For now, on this button, we'll just navigate to the checkout success screen. Once we click on the button, we're taken to the checkout success screen. So let's build the UI for this page. A Save Area widget is used to constrain its content so that they don't overlap with the actions bar on the device. We already have this image in our assets, so we just import it here. And once the user finishes shopping, we want to take him back to the home screen. So we use a navigator which removes all the screens until it gets to the first route. This takes us back to the bag, but we want this to go to the home screen. To fix this, in the tab overlay, we need to have access to the tab controller so that once we click on the button, it takes us to the first route and then moves back to the home screen. To do this, I will remove the tab controller from the tab overlay and make it a static variable in an external file. Within our constants, we'll create a file called apputils. In this our tab controller, we'll best fix all the issues with this error. So wherever we have just the tab controller, we replace it with the apputils.tab controller. This raises a late initialization error. We just need to restart our application at this state and it fixes all the errors. Let's add some items to cart to test this again. So we go back to our checkout success screen and under the navigator, we call the tab controller and animate back to the initial route, which has an index of 0. So once we click on this, it goes back to our home screen. In the next section of this video, we'll be working on the models. The models are the classes that hold the data for our orders. This data is going to be essential both in our payments and in storing the data for future purposes. Our models are going to be created within our orders folder, and we're going to be having 3 models. The first one is the address model. The address model will contain all the details for the buyer, and we would call this the user address model. We'll have the name, phone number, address, city, state and country. Let's use the options to create a constructor. I would also be creating a factory model which uses a map to generate the address model. This will be used later in the course of this tutorial. It will be helpful when we're fetching this address from Firebase or whatever file storage you're using to store your order. The next method we'll be working on is the toJSON. This is a method that converts our model to a map. This is useful when we want to upload this to an online storage, and in our case, we'll be uploading it to Firebase. For our next model, we'll be creating the delivery information. This tells the user the status of their delivery. For our final model, we'll be creating the order model. This would hold both the delivery information and the address model. We'll have the order ID, which is unique for each order, the device ID, which is unique for each device, the status, which is status of our order, the date the order was created, the items in the cart, the delivery fee, delivery information, and user address. I'll create a factory constructor for the order model. This is to allow us to fetch our order directly from Firebase and convert it to an order model. Since we don't have a factory model in the bag item model, we'll go to the bag item model and create one. We'll also create a toJSON method, which is going to return this model as a map. Let's go back to our order model and complete our factory constructor. Because our information is nullable, we'll check if it is null before we pass it through the factory constructor. Finally, we create a toJSON method. Once we finish with our order model, we can go into our setup for Stripe payments. And we go into our pulsespec.yaml and import some libraries. The first library we'll be importing is the device information. This helps us get the unique identifier for the device information, which is used in our order model. The next information we'll be getting is the unique ID. This library helps us create unique identifiers. We'll also be making a HTTP request for our payments, so we'll add the HTTP library. And finally, we'll need the Flutter Stripe library. If you want to learn more about this library, or you want to get the latest version of this library, you can go to pub.dev and search for Stripe. So this is the library we'll be using. The library is called Flutter Stripe. You can get more information on this page about the library. For our Flutter Stripe library, we need some additional setup in the Android folder. So we'll scroll to the Android folder, and within the app, under the SRC, we go into the main folder and open our main activity, which is under the Kotlin folder. In our main activity, we replace this Flutter activity with Flutter fragment activity. Then we go into the rest folder, and under values, we open the styles. Within the styles, we will replace the parent in the normal theme with a new parent. This parent is going to be the day and night no action bar. You can copy it from the code in GitHub, which is going to be the link in the description. And this is required to use the Flutter Stripe library. To add all these changes, we need to stop our application and start it again. If you are running this application and you notice this error, just go back to your Android folder, and within the settings.gradle, look for the Kotlin Android version and change it from 1.8 to 2.1.10. After this, you save the file and run the application again. Before we continue with the application, if you don't have a Stripe account, you can go to stripe.com. You just click on the sign in button at the top. You'll be taken to the login screen. To create an account, you just click on this button to create an account. Here you can enter your email, full name, password, and select your country. If your country is not within this region, you can select anyone just for the test. Once your account is created, you'll be given a free test account which you can use as much as you like. For this our project, we'll be making use of the test account. This is similar to the live account, just that the payments are not real. The information we will need from this dashboard is the publishable key and the secret key. Within the constant, I'll create a file called secret keys, and inside this file, I'll place both of our keys. It is recommended to have an environment file where you place the publishable key. The secret key is not recommended to be used on the front end, but for this tutorial, we want all the implementation to be within our Flutter application. So for this case, we'll have both the publishable key and the secret key within the app. For the final setup for Stripe, we'll go to the main.dat, and within the main folder, we'll set the publishable key. After we do this, we have to restart our application. Let's go to our checkout screen and add the implementation for Stripe. The first step in creating a Stripe payment is to create a payment intent. This is normally created in the back end, but since we don't have one, we'll be making all the calls directly from the app. So underneath the build method, we'll create a function to create the payment intent. Inside this function, we'll make a post request to the Stripe API. We need to import our HTTP library. So we'll go to the top of our application and import the library. Within the header, we'll add our Stripe secret key, which we created in the secret keys file. If the request was a success, we return the body of the request, else we throw an exception. Next, let's add the main function which makes the payments. We'll call this function make payments. Firstly, we need to add all the information for this payment. We add this information using the Stripe instance init payment sheet. This function requires the setup parameters, and I'll explain each of them as we go. First, we have the merchant display name. This is the name of the company collecting the money. The next required information is the payment intent secret. This is the secret that we get from this our payment intent. To get this information, just before the init payment sheet, we call the function to create payment intent. Let's just put a static amount and the currency of USD. We'll be using a light theme because that is the theme that corresponds with our application. For the billing details, we'll need the phone. This is the phone number. The email. This is the email of the user performing the transaction. Then we need the address. This is the address of the user making the payment. Make sure that the country is placed using the code and not the name in full. After the billing details, we also need the billing details configuration. This setup tells the library which information we are going to pass into the payment. We'll always pass in the name, and for the address, we'll never pass the address because we're already collecting it. For the email and the phone, we'll set it to never. This tells the library not to prompt the user for both the email and phone because we already collect this information in the checkout screen. The last thing we will do here is to present the payment sheet. So we use another Stripe function called present payment sheet. Don't forget to go to the build method, and in this function we'll remove the navigator and instead replace it with make payment. So this is all what we need for Stripe. So let's test this out. It seems like we failed to add some information here. In our body, we failed to add the amount and the currency. The amount is the amount we are going to pay in cents. So if this is in dollar, you have to multiply it by 100. So let's test it again. Now we can see that our payment modal has come up. We can make our payment if we so wish. If we close the modal sheet, it raises an exception and we don't want that. So we'll have to catch all the errors in this code. To do this, we'll wrap all the code within this method with a try and catch block. The first exception we'll catch is the stripe exception, and whenever it occurs, we want to show the message on the scaffold messenger. Then we catch any other error that might occur. So once we click it again, we can close this modal without causing any error on the application. Another thing I'd like to add on this screen is a loading indicator, which tells the user that this process is being loaded. To do this, let's go to the top of our widget and we'll use a value notifier. This is a variable that updates the state of a value listenable builder whenever it changes. For our loader, we'll have to update our custom button so that it shows a loader on the button. So we'll go to the primary button widget. We'll add another variable which is going to detect loading, and the default value will be false. So whenever the page is loading, instead of a text, we'll have a circular progress indicator instead. Also, we'll disable the button whenever it's loading by setting it to null. To make sure this updates, we'll have to wrap this our button in a value listenable builder. So remove the button and add a value listenable builder. For the listenable, we'll use the processing payment. Now we can go into our payment method and set the processing payment to true. After the try and catch block, we add the block called finally. This is a block of code which runs even if there is an error or not. So let's test this out. The last step in our tutorial today will be getting the information and using the information to prefill the order and the payments that will be going to Stripe. Since we already have the controllers at the top, we fill the controllers for each of the form fields. To activate the validator on each of our form fields, we need a form state. So using a global key, we create a form state. We'll wrap the whole list view in our form. And within the form, we add the key, which will be the form state. To call the validator, we go into the make payment, and using the form state, we call the validator. This block of code states that if the form is not valid, that is, if it is not equals to true, we should leave this make payment function. Let's test this out. So we can see all our messages being displayed. Now let's add the actual order information into this make payment function. We'll first get the bag, which contains all the items for our checkout. Then we get the price. The delivery fee will be constant. And since Stripe takes in the amount in cents, we would multiply our amount by 100. Using the unique ID library, we generate a unique ID. We also need to fetch the device ID. This is necessary so that we can detect which order came from which device. So let's go below this method and create a function to get the device ID. To get the platform, we have to import the dat input-output library. After we create the function, we add the value as the device ID. Let's create the user address model. Next, we create our order. Since we don't have a public variable to get the list of items, we need to go back to the bag model and add some modifications. We'll create a get variable to get the items. We'll also need a function to clear the cart when we finish our payment. So I'll create a function called clear cart. So let's go back to our checkout screen and we can see that the items is now accessible. Let's replace all the required information into our Stripe function. After we make a successful payment, we want to go to the next screen, so we use the navigator to move to the checkout success screen. And after navigating, we want to clear the bag, so we use the function we just created to clear cart. There's one more block of code we need to add, and this is a function to send our order to Firebase. This tells the company that the order has been made. We'll set the document ID to the unique identifier. Since this value is unique, we'll use it to identify each of our orders. And later in this tutorial, we'll create a dashboard where you can manage all the orders that have been created from your application. So this is the right time to subscribe so that you get notified when I post this content. This navigator is supposed to go to the checkout success screen and not the checkout screen. So let's add the required information. And let's confirm our order. We'll use a test card for this payment. The number is just 424242. And for the expiry date, we can put any future date. So you can see our payment has been successful. And when we click the button, we're taken back to the home page. And if we go back to the bag screen, we can see that it is empty. This is because all the items has been added to cart. Also, if we go to Firebase, we'll see that our order has been added to Firebase. This is how you can add payments to your application. I hope this was a very helpful video. And if this video was helpful for you, it would be nice to subscribe to the channel and like it so that it can reach more and more people. So have a nice day and we'll see you again in our next video. Thank you.